Imagine being hundreds of meters below the ocean's surface, cut off from sunlight and fresh air. How do submarines make this possible? Unlike ships that need to refuel and restock, modern subs can remain submerged for extended periods, operating with near-complete self-sufficiency. Submarines are some of the most advanced engineering marvels. Designed for military, scientific, and exploratory missions, these vehicles function as fully independent ecosystems. Whether patrolling deep oceans for national defense or conducting deep-sea research, submarines rely on cutting-edge tech to survive in the most extreme environments. But how do these underwater machines stay submerged for months without surfacing? What keeps the crews breathing, and the lights on, and the engines running? One of the most critical factors that determine how long a submarine can stay submerged is the power source. Submarines operate on two main types of propulsion: diesel-electric engines and nuclear reactors. The type of power they use drastically affects their ability to remain underwater. Traditional submarines run on diesel when on the surface, but underwater they switch to battery. However, because batteries have limited energy storage, diesel submarines must resurface frequently to run their diesel engines and recharge batteries. This process is called snorkeling and involves extending a tube above the water to take in air. While effective, this need to surface frequently limits operational endurance and makes them vulnerable to detection. Nuclear-powered submarines, on the other hand, don't rely on external oxygen. Instead, they use nuclear reactors to generate power, allowing them to operate underwater for months or even years without surfacing. These reactors provide immense energy, running everything from propulsion to life support systems. In fact, the only limitations on how long a nuclear submarine can remain submerged are food supplies and crew endurance. One of the most well-known examples of a long-duration nuclear submarine is the Ohio-class submarine, used by the Navy. These massive vessels, designed primarily for strategic deterrence, can stay submerged for up to 90 days at a time. The only constraints, the need to restock food and rotate crew. Unlike diesel-electric, which are limited to weeks at most, nuclear-powered submarines can operate almost indefinitely. The development of nuclear propulsion in the 50s revolutionized submarine warfare and exploration, making modern submarines one of the most self-sufficient machines on the planet. By eliminating the need to surface for fuel or air, these vessels can remain hidden deep for a while. One of the biggest challenges of staying underwater for months is maintaining a breathable air supply for the crew. Unlike on land, where fresh air is abundant, submarines create and recycle their own oxygen in a closed environment. To achieve this, they rely on advanced oxygen generation systems and carbon dioxide removal tech, ensuring that the atmosphere remains safe and livable. Submarines use a process called electrolysis to generate oxygen. Since water is composed of hydrogen and oxygen, passing an electric current through seawater can separate these elements, thus resulting in breathable air for the crew. The system provides a continuous and self-sustaining oxygen supply, eliminating the need to surface for fresh air. Modern nuclear submarines use highly efficient electrolysis units that can produce enough oxygen to sustain crews for entire months. This technology is a major factor in allowing submarines to remain submerged for extended periods without external air sources. While generating oxygen is crucial, removing carbon dioxide is equally important. As crew members breathe, they exhale CO2, which, if unchecked, can build up to dangerous levels and suffocate them. To prevent this, the submarines have CO2 scrubbers, which absorb and remove excess gas from the air. These scrubbers typically use chemicals like lithium hydroxide or amine-based compounds to trap CO2 molecules, ensuring that the air inside remains balanced and breathable. Without these, the air inside a submarine would become toxic quickly. Today's nuclear-powered subs are designed to operate as fully self-contained environments, capable of sustaining life for months underwater. The combination of electrolysis, oxygen generation, and advanced CO2 scrubbing systems means that modern submarines like the U.S. Navy's Virginia-class or Royal Navy's Astute-class do not need to surface for air. This technology is not only vital for military subs, but also play a crucial role in deep-sea research submarines, which explore the ocean's depths for weeks at a time. By ensuring stable and safe atmospheres, submarines can function as fully independent water habitats. Surviving underwater for months also requires more than just oxygen. It also demands a reliable supply of fresh water and food. Unlike surface vessels that can restock, submarines must carry everything for the mission. This requires advanced desalination systems and water purification, and careful food storage planning. Submarines do not carry large amounts of fresh water. Instead, they rely on desalination systems, also known as distillation plants or reverse osmosis units, to convert seawater into drinking water. These systems remove salt and impurity, providing drinkable water. On nuclear submarines, the desalination process is powered by the reactor's excess heat, which evaporates seawater. The vapor is then condensed into fresh water. This method ensures a continuous and unlimited supply of fresh water. Beyond human consumption, water is also critical for the sub's cooling systems. Nuclear-powered subs, such as the U.S. Navy Ohio class, use large amounts of water to regulate the temperature of the nuclear reactors. Unlike water, food can't be generated on board, so submarines must carry months' worth of supplies. Meals are planned and consist mainly of frozen, dried, or canned foods that last for long durations. The lack of space means that every inch is optimized for storage, with food often packed into tight compartments. Fresh foods such as fruits, veggies, and dairy are used up in the first few weeks, after which the crew relies on preserved foods. Due to limited refrigeration, food rotation and rationing is crucial. The longest recorded submarine patrol was 111 days, conducted by the British submarine HMS Warspite in 1982. The max length was primarily limited by food storage capacity. Despite these challenges, submarines maintain a strict meal schedule to keep the crew healthy and maintain morale. The onboard chefs play an important role, making sure the crew gets nutritious and high-energy meals to sustain them through the mission. Living in a confined space underwater for months presents another challenge: waste management. With limited space and strict operational secrecy, submarines must handle human waste and trash efficiently to prevent contamination, bad odors, and avoid detection by enemies. Submarines are equipped with advanced sewage treatment systems to process human waste before either storing it or ejecting it into the ocean. Waste is collected in holding tanks, where it's treated to remove harmful bacteria and contaminants. Once the holding tanks reach capacity, the waste is disposed of through a high-pressure system that ejects it into the ocean, ensuring it's dispersed safely. In some cases, the waste is chemically treated before disposal to minimize environmental impact. The system prevents waste buildup inside the submarine, maintaining a clean and hygienic environment for the crew. In addition, modern military subs have bio-friendly waste treatment systems. Unlike sewage, solid trash such as packaging, food waste, and used materials must be carefully managed. Space is extremely limited, so submarines use compactors to crush waste into small, dense blocks for storage. Some materials, like food scraps and biodegradable waste, can be safely disposed of. For military submarines, waste disposal is a strategic concern. Improper disposal could risk detection by enemies, so strict waste management protocols are followed to ensure stealth and secrecy. U.S. Navy submarines follow strict guidelines for waste disposal, using specialized equipment like trash disposal units to release compacted waste in a way that prevents tracking. These protocols ensure that submarines remain undetectable even on long missions. Efficient waste management is critical for the health, safety, and stealth of subcrews, allowing them to complete extended missions without compromising hygiene or security. One of the biggest challenges subs face while staying underwater for months is staying undetectable. Modern anti-submarine warfare tech, including sonar systems, make it crucial for subs to operate as silently as efficiently as possible. To achieve this, submarines use a combination of battery power, energy conservation techniques, and advanced soundproofing tech. Even nuclear-powered subs rely on batteries in certain situations, especially when absolute silence is required. While nuclear reactors provide an almost limitless power supply, they contain moving parts like coolant pumps that generate detectable noise. To avoid being detected, submarines switch to battery power, which operates silently and allows them to run without making unnecessary vibrations. In diesel-electric subs, batteries play an even greater role. These subs charge their batteries while surfaced or using a snorkel that relies solely on battery power while submerged to avoid the noise of running a diesel engine. This method, known as silent running, is critical during stealth operations. However, because battery power is limited, energy conservation is necessary. Sometimes reducing energy usage by dimming internal lights, minimizing electrical equipment use, and limiting movement inside the vessel. Submarines use cutting-edge stealth tech to minimize their acoustic signature and remain undetectable to enemy sonar. Every noise, whether from machinery, crew movement, or even ocean turbulence, can give away a submarine's location. To counteract this, modern subs are built with special soundproofing materials and vibration-dampening systems. One of the most effective techniques is anechoic tile coating, a rubber-like material covering the submarine's exterior. These absorb sonar waves, preventing them from bouncing back and revealing the sub's position. A prime example of modern stealth tech in the U.S. Navy's Virginia-class subs, and these are advanced nuclear-powered subs incorporating low-noise reactor cooling pumps, anechoic tiles, and a revolutionary pump jet propulsion system, instead of traditional propellers. These systems significantly reduce cavitation noise and making them nearly undetectable to enemy forces. By combining energy efficiency, battery power, and soundproofing, submarines can stay hidden while operating deep in enemy waters for months at a time, one of the many reasons they're considered the ultimate stealth weapon. Submarines are among the most technologically advanced machines ever built, allowing them to remain submerged for months at a time. These remarkable capabilities make possible by nuclear power, oxygen generation, water desalination, food storage, and waste management. By utilizing these technologies, submarines can operate in complete secrecy while supporting their crew. From powerful nuclear reactors to stealth coatings and ultra-quiet propulsion, submarines represent the pinnacle of engineering and military strategy. These underwater giants are not just vessels, they're self-sustaining fortresses.